object-oriented programming system, we have total 4 concepts, or we can say we have 4 pillars of object-oriented programming. Although we can add class and object, it will be 6, but mainly we have 4 concepts. And what is that? So to remember that concept, we need to remember a pizza concept. Suppose this is one pizza, and if you will take one piece or one slice from it, right, then suppose if I'll take one slice from it, we say it as a pie. So you have to remember only a pie, and then it will complete your object oriented programming. A pie, A means, so I'll write here, A stands for, I can say, abstraction. Then here we have P. P stands for polymorphism. And then we have I. I stand for inheritance. Then we have E. E stands for encapsulation. So in object-oriented programming, we have only these 4 concepts apart from class and object. In object-oriented programming, we have these 4 concepts: abstraction, polymorphism, inheritance, and encapsulation. So you have to remember API and it will complete this thing. Now, apart from that, we have class and object. So class and object means, let me, so OOPS stands for object oriented programming, and it is an approach to do programming which is based on object. Object means a real life object. There are mainly 6 OOPS concepts in general: object, class, inheritance, polymorphism, abstraction, and encapsulation. Now here, first we can see about the object. So object means anything, right? Anything that we can see in real world, that is in form of object. This particular definition you can remember. In interview also, if they will ask, can you explain about object? Then you can say that anything in real world that we can see, that is in form of object. And in each object will have at least 2 behavior, 2 things: state and behavior. Any object will have these 2 things: state and behavior, right? State means the property. Okay, state means the property, or in programming term we can say this is a variable. State means variable. For example, we can say that if we can talk about animal, right? Any animal. So animal's state can be the animal's color, right? Animal's total number of legs, right? Total number of eyes, ears. These all are countable things, or we can say states. And the behaviors could be, right, walking, running, speaking. These all things are the behavior. So here, if we take the example of phones, so we can say that phone is an object, and the state of phone is phones with different colors, phones with different type and model number. Similarly, we have behavior that make and receive calls, send SMS, set alarm. This is the behavior of phone, right? So this is an example of real object. Here, consider a phone. Now remember that an object always consists of behavior and state. This particular definition you have to remember. An object always consists of state and behavior. In our current example, mobile can have the behaviors like make calls, receive calls, and the states can be a model number, color, type, etc. So we have always remember that state and behavior. Now let's talk about the class. So class is nothing but a logical collection of objects, nothing more than that. For example, whenever we say animals, right? So animals is nothing but we can say a logical collection of different types of animal. For example, I can say dog is also an animal, right? Cat is also animal, cow is also animal. But animal is nothing, just a grouping of things, and or we can say this is a logical thing, right? In this scenario we can say phone, right? So whenever we say phone, then you will say okay, I'm able to imagine what you are talking, but can you tell me what kind of phone? Then you can say okay, I'm talking about telephone or a smartphone, right? Or these different types of phone. Similarly, we can say vehicles. So vehicles is fine. We know that okay, this is vehicle. It may be of two wheels, three wheels, or four wheels, right? But that will be a vehicles. So whenever we say vehicles, you will imagine only about this thing, not about the phone, right? So this is a logical collection, and there is no existence in real world. We can say this is just a logical collection, or we can say a blueprint of real object. So in this scenario, real object is bike, right? Let's say if you will see the bike, and you can quantify that okay, the color, right, size, model number, and these all things, then okay, you can say this is an object of motorcycle or bike. So class is just a logical collection, nothing more than that. In this scenario, we can say, moving with our current example, if an object is a phone, then collection of different types of phone is known as class. If you consider vehicle as a class, then collection of all the vehicle types, car, bike, etc., are considered as object of this class, right? So bike is an object of vehicle class. So I'm so hope you are able to get these two terms, right? Object and class. So why we are talking, because once we work with the actual real project, at that time you have to think on this thing also, that okay, now you are going to create a class. So class will be nothing, just a logical collection of things. For example, here we have created a class, right? So in this class is nothing but simple logical collection of what this is just a blueprint. Then how the objects will be created? So we have to create object manually, although this is fine, but in real world we have to create object and then we have to work on that. So we create object through new keyword in Java, array demo obj equal to new array demo. And once you will do new array demo, then at that time the memory initialization will happen and everything will happen at that time. So we'll see that, and these all things will be clear once we will go through these four concepts, right? Once we will finish these four concepts, you will have the complete idea about object oriented programming, and you will be able to write the program for it, program a program for this also. Any class, for example, I am saying that human, right? So human is a class. Okay, we are human. So human is a class, but that is simply, we can say, the logical thing. There is no existence until and unless we point out to particular object. For example, Chandan is an object, real object of human class, right? That means whenever we say okay, Chandan is real object, that means what all things should have um, in that particular object. So it should have a state and behavior. That means I have a state that I have 2 ears, 2 eyes, right? I have 2 legs, 2 hands. These all are my states. Color, right? These all things you can quantify in that state. And behavior is I can walk, speak, run, right? Think. These all things, whatever things I can do, that is behavior. So if anything which can perform these two things in real world, that particular thing we can say object, and wherever from where I belong, that is object, that is a class. So I'm not a I basically I can say I do not belong to animal class, but I belong to human class, right? Because there are some set of properties. For example, if I'll say, okay, let's start thinking about aeroplane, then in your picture, what in your mind, what picture you can see right now? Aeroplane. But how you think about that? Why you are not able to think about we can say auto rickshaw or bike or vehicle? I mean, that is also a vehicle, but why you are not able to think about auto rickshaw? Why you have imagination of aeroplane? Exact the same picture, because that is logical thing, and we already know about that. If anything will contain at least these features, then I can say, okay, this is a class, this belongs to that particular class, right? So we know that if we have we know the features of aeroplane, similarly we know the feature of human. That is simply logical thing, logical, or we can say blueprint of actual object, or the actual object wherever we see, that is a blueprint of the class. So in real world, each and everything, whatever thing you see in the real world, that is in the form of object, and that object belongs to some class, right? We will discuss this once we are going to see these four concepts. So this is in general term, we can say this is object, this is class. Now once we will go one by one, then you will be able to understand, okay, how these object and class are related to each other. All right. So now next thing is that we can see these four concepts one by one, and we'll try to implement that. So whenever we say about, so now next thing we can start with seeing the definition, and along with that, so before going to see the definition of these four concepts, let me write here how we can implement it. So whenever we say abstraction, we'll see this in detail. So we can implement abstraction two ways. One is we can implement through abstract class. Let me pick. So we can implement through abstract class, and we can implement through interface. Abstract class and interface. So in abstraction we can implement in Java using two ways. One is abstract class, another one is interface. Similarly, polymorphism we can implement in Java in two ways. One is using overloading, another one is using overriding. So these two concepts you have to remember. And then here we have inheritance. So we implement inheritance in Java using extends keyword. Extends keyword. Then we have encapsulation. Encapsulations we can implement using access modifier, access modifiers, and then by creating Pojo class. So Pojo class is also access modifier only, but the thing is, let me write here. So we can say Pojo class. So we have to see these things, and yes, let me save it to, right. So first we can start and we will see about, okay, so next concept what is explaining here is inheritance, right? So let's see the definition, and along with that we can see about it. So the next thing about inheritance. So now inheritance says that it is a special type of relationship. Inheritance is a special type of relationship where a class acquires the acquires the inherent property of its parent class. Along with this is also contains its own exclusive property, right? For example, here it is saying that we have a class that is a phone class. So I can say phone is a parent class. So now phone class acquires the so phone class has some property: make calls, receive calls, redial. And then phone class basically has three child: telephone, mobile phone, and a smartphone. Now telephone has three, behavior: make call, receive call, redial, which is basically similar to the parent one, or we can say parent class things inherited in telephone class. Then mobile phone, since we have added here relationship, parent child relationship, so all the things that parent will have, now it will also come to the child class. So by default these three features will be available in child class. Along with that, child class mobile phone has two more things: send SMS, receive SMS. Similarly, we have a smartphone. In a smartphone, we will have by default these three things: make call, receive call, redial, and then all other extra features that we will have. This is called inheritance. Now you can consider the same scenario in real world, that if we can take example of our parent, right? So we can say whatever thing our parent earned, let's say if they have made they have owned house, right, car, or any property, that by default belong to us, right? Why? Because of the inheritance, because of the relationship between parent and child. And whatever thing our grandparent, so it may possible that we will have one more class on top. So our grandparent, whatever thing earned, that will belong to parent, and then by default that will also belongs to child. So whatever thing in real life we can see in the terms of relationship, we can implement in Java. Right? We will see the example of this. So how, so let's say if we will create one method in parent class and we create relationship, then in child class you don't need to write program again. It will automatically, you will get that. And inheritance basically provides a facility of code reusability. So if you have already written one code, then why you need to write again? Just you can make relationship from the parent class, and the all the codes that is available in parent class will be automatically copied to child class. Right? You don't need to write program for that. So that is called basically inheritance, right? We'll see example of this. And then we have the next thing about polymorphism, right? So hope you are able to get this inheritance. Inheritance means we create a relationship between parent and child, where whatever thing you have already written, it will be copied to child class. And inheritance is used to, we can say, code reusability, used for code reusability. Then next thing is polymorphism. So polymorphism means, poly means more, and then and then morphic means form. So more form, or we can say many form. Poly means many, and then morphic means form. So if we have the same thing available, so this is an example of overriding. Okay, this is we can see polymorphism we can implement in two ways: overloading and overriding. So right now we are seeing the example of overriding. So overriding means, I mean, the thing is here we can simply say we'll focus on overloading and overriding while we go through the polymorphism. Right now we can simply say that suppose if we have a parent class which contains a method that is called bowling method. Now the same class is being inherited by fast pacer, medium pacer, and a spinner. So the same method, bowling method, bowling is implemented by fast pacer. Then this fast pacer will be completely different than a spinner, right? So the same function can behave differently as per the requirement. The same function can behave different as per the requirement. That is called polymorphism. If we take the example of real world, right? So in real world, let's consider about a girl, right, or a woman. So what we can say that about the polymorphism, or we can implement about the polymorphism concept. So a girl can be a sister, can be a wife, can be an employee, right? So one person can behave different. That is basically a concept of polymorphism. Yeah, are you able to, correlate this thing? Polymorphism means maniform. Same person can behave different as per the requirement. So in our company, we can say that one employee can be HR, can be manager, can be software engineer, can be tester, as per the role that is being assigned. So the same person can behave different. So that is the concept of polymorphism. We'll focus on that later once we will go through this one, what is overloading and what is overriding. Then next thing is about encapsulation. Okay, abstraction. And then we have encapsulations, right? So let me first go through the encapsulation. So in encapsulation is basically nothing but a data hiding. Encapsulation means data hiding. Data hiding to make it safe from any modification, right? This is simple in terms. We can say this is polymorphism. If you take the example of capsule, encapsulation is derived from, we can say, capsule. So in capsule, we can see we have one thin layer, and inside that we have some medicines. So if we map in Java, then we can say this thin layer is class, and inside class we have variables, method. So class is a combination of data member and methods. That is encapsulation. So encapsulation is used to protect our data. Now I'll tell you one example, real example. So in inheritance, I explained that whatever thing our parent will earn, right? Or whatever thing our parent is having, now by default, those things belongs to us, right? But there should be some mechanism where if our parent, let's say parent wants that, okay, this particular thing I will not give to my child, even I'll donate it, then what, then there is any provision in Java, right? Suppose my parent wants that, okay, now this particular property I don't want to give my child, my children, then how we can restrict it? So there should be some provision to restrict it, right? And that particular facility is being provided by encapsulation. So you can hide that particular thing and your child will not see it. So whenever we say that by default, all the things you will get from your parent, right? By default, all the things you will get from parent to child automatically, as per the government rule also, and you will get. But there is some mechanism. Yeah, we can implement encapsulation inside inheritance. Now this make call will not be visible to child. Make call will not visible to child. So that particular thing we can do through encapsulation, and that is called basically providing data hide, or providing the security. So in simple term, you can explain that encapsulation is data hiding in order to make it safe from any modification, right? So this is completely theoretical thing as of now, and in interview also you can explain about only theoretical thing, and then we will go one by one to implement it. So suppose if interviewer asks, okay, tell me about encapsulation, you are able to explain that encapsulation is data hiding concept. So we implement encapsulation, we use encapsulation to hide data so that no one can modify it. Now they'll say that, okay, tell me how you can implement encapsulation in Java. Then you can say that we have access modifier and we can use access modifiers in Pojo class, and so no one can access um, without informing or without adding or removing the access modifiers. So using access modifier, we can implement encapsulation. Now, next thing is about abstraction. So abstraction is very big topic, I can say, a very big thing. So once we understand that, okay, what is object, what is class and other properties, then we can say the abstraction will be our last topic in the OOPS concept. Why? Because abstraction implements all other things that we have. It will use overloading, I mean polymorphism concept, it will use encapsulation concept, it will use inheritance concept, all the things in abstraction. So we can say the abstraction is final product. Now the definition is, abstraction means hiding the complexity and showing the easier form of the system. So data hiding is different. Data hiding is different. Encapsulation means data hiding. Abstraction means hiding the complexity and showing the easier form of the system. That means, suppose if you have a mobile phone, right? In mobile phone, what things you can see? You have a big screen, right? Then you can see you have three buttons. One is to screen on off, or we can say switch off the phone, and the two buttons are just to minimize the sound and maximize the sound, increase and decrease volume, right? Only these three buttons, and along with that one is to for fingerprint, we can say. So these 4 5 things is only provided. Why? Because it uses abstraction concept. Abstraction says that hide all the complexity. You don't need to show battery, you don't need to show how once we press on a screen, then how this screen functionality works, right? Once we touch, then how it performs internal operations. You don't need to show anything, just show the easier form of the system and hide all the complexity. That is the concept of abstraction. So in Java, we implement abstraction in two ways, that is called abstract class and interface. Another example could be that in our home, we can say we can see that fan and light, right? Fans, we have a light bulb, and for all we have connectivity through one socket, right? So we have one socket, we can press button and then we can see that fan is on. We can press button, light is on. So if you can see that interface socket, right, we have buttons, and how wiring and all things happened, we completely, that is hidden, right? Wiring things is hidden. You only need to know, okay, if you will press this button, then fan will be on. If you will press this button, then light will be on. That is called abstraction. In this example, it is saying about explaining about the motorcycle. So consider bike as shown in the picture. We all know about the bike consists of various sophisticated parts like ignition system, exhaust pipe, wheels, brake systems, etc. As a bike rider, we are not aware of the internal complexity and internal functionality of various parts of system. In order to make it, in other words, this complexity and internal functionality is hidden from us because as a bike rider, we do not bother how complicated parts are implemented each other. As a bike rider, we only need to start our ignition system and change the gear to ride the bike, right? So this provides easier form. You only need to know few things, right? to operate the system, and that is called abstraction. So now I can say that everything you see in the real world is in form of abstraction. Is in form of abstraction. You can pick any object, and that is in form of abstraction, because that is provided the easier form and hides the complexity. So that is all the theoretical concept about the object oriented programming. Oops.